Today we will learn applications of stack. We already learned how to convert an infix expression corresponding to its postfix or prefix expression using stack. For solving a mathematical expression, we need prefix or postfix form. After converting infix to postfix, we need postfix evaluation algorithm to find the correct answer. Here also we have to use the stack data structure to solve the postfix expression. So today we will learn evaluation of postfix expression. So how we can evaluate? Say this is one equation. This is infix expression. If we calculate this mathematically, what is the result? It is 3. So how to evaluate this expression and get the result using stack? So the postfix expression of above infix expression is this. How to convert postfix to infix using stack? We already learned this thing in our previous video. Please consult our previous video, then it will be more clear. So first, your task is to convert this infix expression corresponding to its postfix expression. Now, take one stack and this one is one table. The column are OP1, that is operand 1, OP2 operand 2, this one is result and this one is operator. So how we can evaluate? First you have to scan from the left hand side. If it is operand, then push it onto the stack. So first 3 is an operand, so push it onto the stack. Then comes 4 is also an operand, push it onto the stack. But when an operator comes, then you have to pop. So first plus comes, plus is operator, write plus here. Now you have to pop. Stack follow LIFO rule. So first you have to pop 4. But remember 4 is OP2 and 3 is, then pop 3 is OP1. I repeat, first popped element will be OP2 and second popped element will be OP1. Now calculate the result. It is 7. Push 7 onto the stack. Now it comes 2. Again scan this string. It is 2. So push 2 onto the stack because 2 is operand. 7 is also operand. Push 7. Now it comes into. If into comes, write into here. Now you have to pop. First popped element will be OP2 and second popped element will be OP1. Calculate the result, it is 14. Push 14 onto the stack. Now it comes minus. Write minus here. So first popped element is OP2. Second popped element is OP1. Calculate the result, it is minus 7. Push minus 7 onto the stack. Now it comes 8. 8 is operand, so push it onto the stack. Now when operator comes, you have to pop. Just write plus here. First popped element will be OP2. Second popped element is OP1. Calculate the result, it is 1. Push 1 onto the stack. Now it comes 2. 2 is operand, so write it onto the, push it onto the stack. Now it comes plus is operator, you have to pop. So first popped element will be OP2. Second popped element will be OP1. The result is 3. Push 3 onto the stack. Finally, we get the result after popping the stack. So, lastly, we get the result after popping it. So, pop the stack and get the result. So, the result is 3. In this way, you can evaluate any postfix expression. Now, it's time to practice. So, let's practice. Evaluate the following expression. First, you have to convert it corresponding to its postfix form. So, see, Evaluate the following expression. First, you have to convert it corresponding to its postfix form. So, this is the infix expression. First, you have to convert it corresponding to its postfix form. How to convert an infix expression to its postfix form manually or using stack? We already learned this thing in our previous video. Please consult our previous video, then it will be more clear. So, here I convert it manually. So, the postfix expression corresponding to this infix expression is this. Now I have to evaluate it. So, take one stack and one table. Okay. So, first, if it is operand, you have to push it onto the stack, and if it is operator, you have to pop. So, first, scan from the left hand side. So, first it comes 2, 2 is operand. So, write it onto the stack. Then it comes 3, 3 is operand. So, write it onto the stack. Then it comes 6, 6 is also operand. So, write it onto the stack. Now it comes into. If into comes, you have to pop. Into is an operator. So, write into here. First, you have to pop 6 because stack follow LIFO rule. First pop 6 and it becomes OP2. Second pop 3, it becomes OP1. Calculate the result, it is 18. So, delete this one, remove this one and remove this one. Calculate the result, it is 18. Write 18 here. Now it comes 2. 2 is an operand. So, write 2 here. Now it comes division, divide. So, write divide here. Now you have to pop. First popped element becomes OP2 and second popped element becomes OP1. So, the result is 9. Now pop 9 here. Now it comes plus. So, write plus here. Now you have to pop. First pop element is OP2. Second popped element is OP1. Calculate the result. It is 11. So, push 11 here. Now it comes 4. Write 4 here. Now it comes minus. If minus comes, you have to pop. So, minus, write minus here. First popped element is OP2. So, write 4 here. Second popped element is OP1. Calculate the result. It is 7. Push 7 here. Finally, you get the result 7 after popping the stack. So, pop the result from the stack, write it here. So, the answer is 7. Now, calculate it manually means calculate it mathematically. You get the same result. The result is 7. So, in this way, you can evaluate and postfix expression. Now, your task is to try to evaluate this expression and get the result. Practice this problem, and if you are facing any problem, then feel free to comment in the comment section. Now, the algorithm for evaluation of postfix expression. First, initialize the stack as empty. First, you have to initialize, take one stack and that stack will be empty. So, initialize the stack as empty. I start one while loop till while not end of input string, till the input string is not reached to the end. Here the input string is our postfix string. So, I have to scan the postfix string from the left hand side till we get the end of the input string. I have to scan total input string. Okay. Now I have to scan each character and I give name of those character as symbol. So symbol equals to next input character. If the symbol is an operand, then you have to push that symbol to the stack. And if the symbol is operator, then you have to pop from the stack. So first popped element is OP2, second popped element is OP1, and OP1, OP2 and symbol, calculate the result with OP1, OP2 and symbol. Here symbol is operator. So calculate the result and store it to the variable value and push the value onto the stack. In this way, this while loop continues till the end of the postfix string is or given input string is reached. So I repeat, if the symbol is operand, then you have to push. If it is operator, then you have to pop. First pop element is OP2, second popped element is OP1. Calculate the result, insert that result onto the stack, calculate the result, store it to the variable value, push the value on the stack, and in this way this while loop continues till the end of the input string reached. Finally, we get the result after popping the stack. So final result is stored in stack. We get the result after popping the stack. Now we will learn how to evaluate a prefix expression. So the given infix expression is 3 plus 4 minus 2. So what is the result? It is 3 plus 4, 7 minus 2, it is 5. So you have to evaluate corresponding to its prefix expression. So first you have to convert this infix expression corresponding to its prefix expression. How to convert an infix expression corresponding to its prefix expression using stack or manually, we already learned this thing in our previous video. Please consult our previous video, then it will be more clear. So first you have to convert this expression corresponding to its prefix form. Now you have to start scanning from the right hand side. In case of evaluation of postfix expression, you have to start scanning from the left hand side. But in case of prefix expression, you have to start scanning from the right hand side. Okay. So it comes 2. 2 is operand. So you have to push it onto the stack. Then comes 4. 4 is also operand. Push it onto the stack. Then comes 3. 3 is also operand. Push it onto the stack. Now it comes plus. Plus is operator. So write plus here. Now you have to pop. In case of postfix expression, you have to pop the first element and it is OP2. Because stack follow LIFO rule, in case of postfix expression, you have to pop the first element and it is OP2. But in case of prefix expression, you have to pop the first element and it is OP1. So pop the first element, it is OP1, then it is OP2. Calculate the result and store it onto the stack. Then it comes minus, write minus here. Pop 7, it is OP1. And then pop 2, it is OP2. Calculate the result and push it onto the stack. Finally, we get the result after popping the stack. So the result is 5. Now, the difference between postfix and prefix expression is that first you have to convert given infix expression corresponding to its postfix expression in case of postfix evaluation, and in case of prefix evaluation you have to convert it corresponding to its prefix form. Now in case of postfix evaluation you have to start scanning from the left hand side. In case of prefix evaluation you have to start scanning from the right hand side. And when we pop element from the stack, first popped element is OP2 and second popped element is OP1 in case of postfix evaluation. But in case of prefix evaluation, first popped element is OP1 and second popped element is OP2. So these are the difference between evaluation of prefix and postfix expression. Take more example and practice. So let's practice. See, this is our infix expression. I have to evaluate it. Okay. So first you have to convert it corresponding to its prefix form. How to convert an infix expression corresponding to its prefix form? We already done it manually. How to convert an infix expression corresponding to its prefix form using stack or manually? We already done this thing in our previous video. Please consult our previous video. So this is our prefix expression. We have to evaluate it. So first scan from the right hand side. So if it is operand, push it onto the stack. So this is our stack. I push it, this operand. Then 8. Push it, it is operand, so push. Then it is 7. So push. Then it is 2. So push. Now it comes into. So this is operator. Now this comes into. If it is into, then you have to pop. First write into here. Next pop 2, because it is prefix evaluation, it is OP1, and pop 7, it is OP2. Write the result, it is 14. Push 14 here. Next 4, 4 is operand, write 4 here. Next 3, 3 is operand, write 3 here. Now it comes plus, plus is operator. So write plus here. Pop 3, it is OP1. Pop 4, it is OP2. The result is 7. 7 will be pushed. Now it comes minus. Write minus here. Pop 7, it is OP1. Pop 14, it is OP2. Result is minus 7. Minus 7 will be pushed. Next it comes plus. Pop minus 7, it is OP1. Pop 8, it is OP2. Result is 1. Push 1 here. Now it comes plus. Pop 1, write 1 here. Pop 2, write 2 here. Result is 3. Push 3 here. Finally, when we pop the stack, we get the result. So pop the stack and the result is 3. So this is our result. In this way, prefix evaluation is done. Now your task is to first convert this infix expression corresponding to its prefix form and evaluate this expression. And if you are facing any problem, feel free to comment in the comment section. Now the algorithm for prefix evaluation. Initialize the stack as empty. First you have to initialize your stack and it is empty. Now reverse the string. That is, in case of prefix, we have to start scanning from the right hand side. So reverse the string. While not end of the input string, here the input string is prefix string. Scan the next input character and store it to the variable symbol. Okay, if the symbol is an operand, then push stack symbol, means push that symbol onto the stack. And if it is operator, then pop the stack. First popped element is OP1, Second popped element is OP2. Calculate the value of OP1, OP2 and the symbol, here symbol is operator, and store the value to the variable value and then push the value into the stack. In this way, this while loop continues till the end of the input prefix string rest. After that, pop the stack and get the result. Now, what are the changes between the algorithm of postfix and prefix? This line reverse the string. In case of postfix, we start scanning from the left hand side, but in case of prefix, we start scanning from the right hand side. That's why you have to write reverse the string. And here, in case of postfix, OP2 is first popped element, OP1 is second popped element. But in case of prefix, OP1 is first popped element and OP2 is second popped element. And remaining all are same. Now we will learn programming for postfix evaluation. So see the code. In this program, we want to evaluate any postfix expression using stack. So see, first you have to include the header file stdio.h. Then I declare one integer stack. The size of the stack is 20. I initialize the top as -1 because initially our stack is empty. So top is -1. Now the push function. I want to push that element. I have to pass that element. So the element is x. Now first you have to increase the top, then insert the element. So here I use prefix operator, prefix increment operator. So first increase the top, then insert the element. In this way, push function works. Now it comes pop function. In case of pop function, first you have to remove that element which is pointed by the top. So remove stack top, then decrease top. In this way, pop function work. And you have to return the popped element. So the return type is integer. Now the main function. In main function, first this is one character array for storing postfix expression given by the user. E is a character pointer that can hold address of a character. Declare some integer variables, they are required later. First, give one printf statement, enter the expression, take the input postfix expression, store it to this string exp. So, e equal to exp means base address of that string is stored to this variable e. I repeat, base address of the given string is stored in the variable e. Now, I start one while loop star e not equals to /0 means till the end of the string this while loop continues. Star e means value at e. So till the end of the till we get /0 this while loop continues. If is digit star e means what? Is digit any character is a function in C which can be used to check if the past character is digit or not. So if I write is digit any character, then it is a function in C which can be used to check if the past character is a digit or not. If it is digit, then push that character onto the stack. Okay. So first you have to convert that character to corresponding to its integer. First you have to convert because it is character. I take it as a string because it is character. First you have to convert it as an integer. So you have to write num equal to star e minus 40. So I convert it and make it integer and store it to the variable num and push num onto the stack. So first convert it as integer, then store it to the variable num and push that integer to the stack. Otherwise, if it is operator, else then first pop pop the digit and store it to n1. Second, again pop the digit, store it to n2. Now I use here switch case control statement. Switch star e. If the value of star e is value at e, means value of star e is plus, then it is a case of addition. Then there is another variable n3, n3 equals to n1 plus n2. Otherwise, if it is, if value of star e is, if star e is minus, then into minus n1. If it is into, then n1 into n2. It is a case of multiplication. So n3 equals to n1 into n2. If the case of subtraction, it is n3 equal to n2 minus n1. And if it is the case of division, then n3 equals to n2 by n1. And every time, don't forget to write this break. Usual case control structure. Now, after that, you have to push n3, means after calculation, get the result, push that result to the stack. Now, after that, you have to again scan the next character. So, E plus plus. E plus plus means scan the next character till we get this /0 till the end of the string. Now, after that, finally we get the result after popping the stack. So, finally we get the result when we call the pop function, we get the result. So, final result get printed. In this way, these programs works. Now, when we run the program, enter the expression. Here you have to give postfix expression. Say the given postfix expression is 3, 4 plus 27 into then minus 8 plus 2 plus. So the result is after evaluation is 3. In this way this program works. Now your task is to change this program little bit and try to execute how to evaluate any prefix expression. Till now, we already learned how to convert an infix expression corresponding to its postfix or prefix form. Today, we will learn how to convert any postfix expression into their equivalent infix form. So, the postfix expression is given. You have to convert this postfix expression corresponding to its infix form. So, we start scanning from the left hand side. First 4, so character scanned is 4, push it onto the stack. Then 2, if 2 is operand, so push it onto the stack in between 4 and 2, give 1 comma. Then if any operator comes, then just replace this comma by the operator. Now it comes 3. Now it comes into. If into comes, then replace this comma by this into. Now it comes 3, give 1 comma. Now minus comes. If minus comes, then replace comma by this minus. Then it comes 8. Then it comes 4. Just give 1 comma. Now it comes by. Now there are 2 comma. Which comma will be replaced? Think for 5 seconds. Which comma will be replaced? Yes, stack follow LIFO rule. So these comma will be replaced. So now it comes 1. Just give 1 comma. Then it comes another one. Give 1 comma. Now it comes plus. So these comma will be replaced because stack follow LIFO rule. Now it comes by. So these comma will be replaced. Now it comes plus. So this comma will be replaced. Finally, we get the infix expression corresponding to the given postfix expression. So these are your programming assignment. Try to execute this program and feel free to ask any question. Try to execute this program in your home. We already learned how to evaluate a postfix expression. We already learned how to write this program. Now your task is to first execute this program and try to write a program to evaluate a prefix expression also. After completion of this chapter stacks, try to answer this question. If you are facing any problem, feel free to ask in the comment section. Pause this video, try to answer this question by your own. These are your homework. Choose the correct option and answer me in the comment section what is the correct option. I am waiting for your reply. Pause the video, try to answer this question. Pause the video, try to answer this question. I am waiting for your reply. For getting more and more updates, please subscribe my channel. That's all for today. Thank you.